Okay, here we go. Now we've hooked up just an automotive light bulb, 12-volt battery. We're looking at voltage on the bulb and amperage in the circuit. So now we're going to have the little 1 ohm resistor. You can see that it's dropped slightly. And the resistor's getting warm because it doesn't like it. So here's the same resistor in a group of 10 in series. So we're going to start off with 1, 2, 3, and so on as it gets dimmer, down to almost nothing, and barely see the bulb going. The meters are almost dead because it's going through 1, 2, 3, 4, 5, 6, 7 resistors here, 10 ohms a piece, so 70 ohms. Now we're going to go to a variable resistor. Now again, we start at full power. Now you're going to see this as I roll it back. It's getting dimmer and dimmer and dimmer. You can see the meters are going down. The bulb is still glowing ever so slightly, but the voltage, I'm going to drop it down to another scale. This is now a 10-volt scale, so we're below 4 volts. There's about 3.5 volts, and as you can see, the amperage and the voltage kind of go up and down together. Oops, that was on too low a scale. I'm just adding resistance to the circuit here. All right, now we're going to take a stove element. This is about 20 ohms. And there's full voltage. That's the stove element. So this will make sense later on when we start getting into higher voltage. But this is actually creating a tiny, tiny amount of heat, but it's very small. But again, it's a stove element. Everybody's seen it. It's 20 ohms. All right. We're moving into understanding resistance here.
I know.
The unit of measurement in resistance is ohms, anywhere from 0 to almost infinity. 0 ohms is a piece of copper wire, no resistance of any kind. Whereas this, you've all seen before, stove element, small burner, it's about 30 ohms. Runs on 240 volts, but it is a fixed resistor. This is a variable resistor. By moving this slide up and down, you can change the resistance, and this is only 1 ohm. This is also a variable resistor. It's hooked up to a knob, changes the resistance. This unit is 60 ohms, but it's variable. This is a photocell, which means it's light sensitive. And how it works, its resistance changes with brightness. So I'm going to hook it up to an ohm meter and show it to light. Now, this is the unit here, and I'm going to show the light being cut off. The needle should be dropping and coming back up to brightness. Again, light, dark, and that's all it does. The resistance changes in ohms. Now I have another one here. It's a little smaller, different sensitivity. And this technology's been around for a very long time. It's not new. There we go. Now we got a little tiny one. And again, I'm going to be adjusting brightness that it sees. That should be fairly low. coming back. And that's about it. Again, a variable resistance varies in ohms by brightness.
Sabertooth. You know that lunatic?
So, I'm in my 38th year of doing this now. I'm a union member of IATSE, Local 873, here in Toronto. And I've done over 50 movies in my career. And, anywhere from a week to months, sometimes more. X-Men was pretty much a year from start to finish here in Toronto. I work within the creature. The creature is a concept that's illustrated, is drawn, shown to production. Art department gets modified, and eventually they settle on a design of the creature. Then sculpting begins in sculpting wax to get the size and shape and all the nuances. And I go with a tape measure and start measuring where all the joints are and figure out how I'm going to make it move. Does it need to move remotely under power? Is it just going to be a poser, like a statue that you could pose? Or somehow interactive? Every build is different. Anywhere from a newborn baby to a creature that's huge, as big as an elephant. And you never know what you're going to get. All right, the next experiment, we're going to use an LED that uses a very small amount of amperage. And this is a photocell, which is a variable resistor. Its resistance changes with brightness. So I'm going to hook it up to power. And there's the voltage that's getting to the light. We're on a 10 volt scale, so we're a little over 6 right now. And as I put my hand in front of this and block the light, you can see it getting dim, more and more and more and more. And then I can take this quarter and I can just blank it right out. So full brightness, dead, and everything in between. Once again, it dims with light being cut down. This is how a light meter works from years ago. And you could fashion a simple light, not a meter, but a comparator, by establishing a brightness and seeing if something's going up and down by shining on this. So again, a variable resistor driving a very small load.
It's time to send you home to mommy.
So let's get into the resistance department. All right, this resistor is labeled on the package as 820. I get 810. That's normal that they're close. So I'm just proving that this is correct. Now I'm going to measure the resistance of this potentiometer because I haven't touched it. .250, that's 1,250 ohms, 1250. It's not a size in my collection here, but you can probably buy a resistor of that value, because this is more of a general kit. But let's say it's 1.2, well, you could get there with a pair of 600s. So I've got 680 or I've got 560. So if I had one of each, I'd be very close. So I could put two of them in series. Let's just prove that. So I'm going to take a 680 and a 680, 560. What am I looking for? 1250. And I'm going to put them in series. So I just want one into the other. 1226, close enough. So I've created it with, one of these, one of those. So just to prove it, we'll hook the LED back up with the new assembled resistor package. It's the dust. All right, so negative goes there. The gator clips are slippery and they're hard to open. Now we're in resistance mode. I got to go back to milliamp mode. There we go, nice and bright. 17.8 milliamps, still under the 20, but we've done it with resistors. So you could run this on 24 volts. Now, you could also run it on 12 volts. It's not as bright, but it's only drawing 7.8. This will last forever. So once again, the idea here was to, when you're hooking up an LED, see what the battery, the most convenient one is. You need 3 volts. Most LEDs are around 2.5 to 3 volts. So if you have 3, pair of AA's, AAA's, just try and find 20 milliamps or less.
The war room.